Number one is a system of equations. You need to graph this first function, y equals 3x minus 2. The slope is 3, and the y-intercept is a negative 2. So it's a linear, it's going to be a straight line. Start with your y-intercept. So at negative 2, you're going to have a dot. And if your slope is 3, that means rise over run, go up 3 over 1. Up 3 over 1, up 3 over 1. And you're going to have a line through all these dots. Now your other line, the slope is a negative 1/2, and the y-intercept is 5. So the y-intercept is your first dot, starts up here at 5. Go down 1 over 2, down 1 over 2, down 1 over 2. So if you draw a line through these dots, the solution to a system of equations is the intersection of where they cross. So this solution is going to happen right there. The answer is over 2, up 4. That is the solution to that system. Number 2. Okay, they've got a graph here that represents the price in shipping pounds of cherries. So they want you to come up with a new line that has a smaller shipping fee, but at the same time keeps the price per pound of cherries the same. So this right here is a big deal. This 0 pounds is going to cost you 20 bucks. So that's kind of our shipping. So if we need to have a smaller shipping, let's start it out at 10. And we're going to keep the slope the same. The slope is going to represent the rate of change, and that is the cost per pounds of cherries to ship. So the slope needs to stay the same. You're going to charge the same to ship the pound of cherries. It's just going to be smaller shipping fee. So our line needs to be parallel, but it needs to be a little bit underneath 20, and there's several right answers. Okay, number 3. Kind of a similar type of problem. There's several right answers. You need to have at least 8 data points that show the trend of the more you read, the higher your score is going to be. So a scatter plot is a sample of hundreds of data points, and if you plot them all, if you want it to show a positive correlation, they kind of need to be tightly grouped together, but they've got to have a direction that is a positive slope, so that the more the exams increase, so if I got a 90% exam, that maybe correlates to 9 books read, something like that. So the only wrong answer is if you would have them grouped loose all over the place where there's kind of no pattern, or if you had them trending the wrong way, if you had them trending down. Okay, number 4. 2 polynomials are given. Find the product. That's multiplication. So x squared plus x minus 3 needs to be multiplied to 3x plus 8. So you need to distribute x squared to both terms. X squared times 3x is going to be 3x cubed. X squared times 8 is going to be 8x squared. X times 3x is going to be 3x squared. X times 8 is going to be 8x. A negative 3 times 3x is going to be a negative 9x. And a negative 3 times 8 is a negative 24. Now add up your like terms. These are the only cubes I've got, so 3 cubes, and then 11 squares, a negative 1x, and a negative 24. So if I multiply those 2 polynomials, that's what I get. Number 5. They're using kind of an area model. You need to show x minus 2 times x plus 5. So I'm going to times this piece to this piece. X times x, that's x squared. X times 5, that's 5x. Negative 2 times x, that's negative 2x. And a negative 2 times 5 is a negative 10. So in each cell, you need to have these corresponding terms. Number 6. Okay, this is kind of a mean problem. They want you to expand 2x plus y to the fourth. That is 2x plus y times itself over and over again 4 times. So you need to distribute, and that's going to give you 4x squared. 2x times y is going to be 2xy. Y times 2x is going to be 2xy. Y times y is going to be y squared. And add your like terms. These are your like terms. So you're going to have 4x squared plus 4xy plus y squared. Okay, now that is the product of two of them. And I know I'm going to have the same answer if I multiply these two together. So I'm going to take this answer and times it by itself. 4x squared plus 4xy plus y squared. Now if I times it by itself, 4x squared times 4x squared, that is going to give me 16x to the fourth. 4x squared times 4x is going to give me 16x cubed y. And 4x squared times y squared is going to give me 4x squared y squared. And then we got to do the same thing with this 4xy. 4xy times 4x squared is going to be 16x cubed y, so that's the same term as that one. 4xy times 4xy is going to be 16x squared y squared. And 4xy times y squared is going to be 4xy cubed. Okay, now I just got to times the y squared through. Y squared times 4x squared is going to be 4x squared y squared, so that matches up in this column. Y squared times 4xy is going to be 4xy cubed. Y squared times y squared is going to be y to the 4. And now you got to add up all your like terms. So these have no like terms, so my final answer is going to be, I guess, here we go. I'm going to put the 16 there. Now they want to know how many x cubed y's we got. That's these guys, x cubed y's. I'm going to have a 16 to 16. That's a 32. 24x squares y squares. How many xy cubes? I got 4 and 4. That's going to be 8. So that's it. 16, 32, and 8. Okay, 7. Don't worry about 7. That's kind of a math 3 problem. That's not going to show up. 8 will show up. They want you to find the zeros. They want you to find zeros or roots. Zeros are where you graph it and it crosses the x-axis, because that's when y is 0. And because this is a cube, you look at the biggest exponent. The biggest exponent is 3. That means it's going to have 3 zeros. If it's a linear only crosses once, so there's only 1 0. Quadratic, that's going to usually cross twice. Cubic's going to cross 3 times. So you need to find the roots, and you should expect 3 of them. Okay, zeros are easy to find if you can factor it. So let's factor this polynomial. If you've got 4 pieces, you need to factor by grouping. I'm going to group the first 2 together. If you group the first 2 together, divide them both by the GCF, which is x squared. So x squared times, if you take an x squared out of each of these, what's left over is an x and a minus 2. Okay, your last two terms, negative 3x plus 6. Divide both these by as much as you can. Divide them both by 3. So it's going to be 3 times a negative x plus 2. And now the problem is my signs don't match up. This one is x minus 2. This one is a negative x plus 2. So you can change that pretty slick. Don't divide by 3. Divide by negative 3. So negative 3 divided by negative 3, that's going to be a positive. And 6 divided by negative 3, that's going to be a negative 2. Okay, now your signs match up. So now your answer in one of the groups is going to be x minus 2, and the other group is going to be x squared minus 3. And that is going to equal 0. So we need to know what we're going to put in place of x to really make it spit out a 0. So this one's easy to do in your head. You're going to replace x with 2 because 2 subtract 2 is 0. So one of your zeros is 2. This one's not as easy. What are you going to put in place of x? Then you got to square it and then subtract 3, and that's 0. So the question is x squared, make it equal 0. Just set it equal to 0 and undo the operation. So undo the minus 3. Plus 3, you got x squared equals 3. Now undo the square. So square root, so you got x equals a plus or minus square root of 3. So your other two roots are a square root of 3 and a minus square root of 3, and those are your 3 zeros. Okay, you need to complete the square. Complete the square if you are given x squared plus 2x. What would you put for C to make this a perfect square? And to complete the square, it all depends on B. The formula is you take B and you cut it in half, and then you square it. So take B, cut it in half, 2 divided by 2, that's going to give you a 1, and now square that, that's going to give you a 1. So what you want to complete the square is you want a 1 here. Now look, if that's a 1, you're looking for something that's going to times and give you 1, but add and give you 2. And that is a 1 and a 1. So you can factor this to x plus 1 times x plus 1. It's always going to be times itself because that's the definition of a square. So you can rewrite that as x plus 1 squared. And if you're going to add a 1 on this side of the equation, you've got to add a 1 on this side of the equation. So on the right hand side, you're going to have a total of 6. And on the left hand side, you can change that to x plus 1 squared. So to complete the square, take the middle, cut it in half, and times it by itself, and that's the number that will create a perfect square. Number 10, they're giving you a graph of x squared plus y squared is 8. That's what is shown, and that is a circle. So you got this circle right here. They want you to graph y equals a negative x. That's a linear function, so it's going to be a straight line. Your m is a negative 1, and your b is 0. So 0 is your first dot. Then you're going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1, and you're going to have a line that goes through all these dots. Okay, the solution to this system is like we did before. The solution is where they cross. The solution is that dot right there, where my line crosses the circle, and this line right here, or this dot right here. This dot, how I get to this dot is a negative 2 up 2, and how I get to this dot is over 2 down 2. So those are my answers. Negative 2 up 2, and I probably don't even need to put the positive, but over 2 down 2. So in the circles, they want you to put the sign, positive or negative, and I guess they just give you negative. So if it's positive, leave it blank, and then in the boxes, they want the numbers. Find the zeros. So the zeros are the roots. The zeros are what you're going to put in place of x, so your answer is 0. You can now factor this. This is awesome. It's not easy to factor because it starts with a 2. And I cannot divide them all by 2 because 5 is odd, and 2 is not going to go into 5. So, if you have a quadratic and it does not start with a 1, you need to break up your middle into 2 pieces. So this negative 5, you need to rewrite negative 5 as 2 terms instead of 1 term. So you're going to keep the first, you're going to keep the last. you're going to take the first and you're going to times it to the last. So 2 times a negative 12 is going to give you a negative 24, and that is your number. You are going to look for something that timeses and gives you a negative 24 but adds and gives you a negative 5. And you should come across a negative 8 and a positive 3. So you're going to rewrite 5 as a negative 8x and a positive 3x, because a negative 8 plus 3 is a negative 5. And a negative 8 times 3 is a negative 24. So now that you've got them as 4 pieces instead of 3, group them. Group these two together. Divide both of those by 2x. Divide that by 2x. Divide that by 2x. So it's going to be 2x times x minus 4. Divide this group, the 3x and the minus 12, divide them both by 3. So it's going to be 3 times x minus 4. And now your final answer, one of the groups is going to be x minus 4, and the other group is going to be a 2x plus a 3. So if you want that to equal 0, what you're going to substitute in place of x, this one's easy. You're going to substitute a 4. This one's not as easy. What are you going to times by 2? And it needs to be a negative 3, because a negative 3 plus 3 is 0. So this has to be a negative 3, but what the heck times 2 is a negative 3. So just do 2x plus 3, make that equal to 0. Minus 3 minus 3, so it's 2x equals a negative 3. What times 2 is going to give you negative 3? Divide by 2, divide by 2. X is going to be a negative 3 halves. So these are my two zeros. And if you're going to plug them in, if you're going to write it as a fraction, it needs to be 4 over 1 and a negative 3 over 2. Okay, number 12. Okay, these are awesome. We've done a bunch of these transformations. If you add outside of the parentheses, that's a vertical translation. If you add inside the parentheses, that's a horizontal translation. That slides left and right. So the black one is the original one. That's f of x. If you take f of x and at the very end, outside of everything, you minus 2, that means you're going to vertically shift it down 2 units. So this red one, all you do is copy and paste it. It's a rigid motion, so translate it down twice. The blue one, if you add or subtract in the parentheses, that's a horizontal translation. And the model is this. So a x minus h squared plus k. This a, this is the dilation. If it's negative, it flips it upside down. If it's positive, it's right side up. And the bigger the number, if a is 10, it's going to be steep. So it changes the slope. And we call it, if it's a quadratic, that's a dilation. Okay, this h, this slides it left and right, and the k slides it up and down. But there has to be a minus in the model. And b is kind of tricky. If it's x plus 3, and there must be a minus in the model, that means it's really x minus a negative 3. So this 3 is not positive, this 3 is actually negative. So that means we need to go to the left. So if you're going to slide it 3 units to the left, it's going to look something like that. So make sure there's a minus in your model. If there's not, there's kind of a hidden invisible one. Okay, 13 is kind of the same thing, a translation. So we need to graph x plus 3. The b is 3, that's this guy. The m is the number in front of x, the m is 1. So your first dot is 3, then up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Your line, compared to this line, they just added something at the very end, so they vertically translated it. And this line my blue line compared to theirs, what does k have to be? K has to be a -2, because all they did was take these dots and translate them down 2 units. So k is a -2. Because if you shift that line down twice, it will land right on top of that line that's given. Okay, same thing. If you've got x minus 4, okay, now we're in business because the minus is there. So don't look at the minus, you're looking at the 4, and the 4 is actually positive. So you need to take this and shift it to the right 4 units. Okay, same thing. You need to write the equation g of x in terms of f of x. So g of x is just this. To get g, all I did was I slid it 1, 2, 3. I slid it over 3 units to the right. So I took f and I'm going to put a +3 in the parentheses. So the minus has to be part of the model. So this is it. You just took f and you slid it over 3 times to the right. Okay, the original, oh man. So the original is just x squared. X squared, if you shift it 3 units left and 1 unit down, here we go, x squared, if you shift it 3 units to the left, so it's going to be x minus, left is a -3, and then 1 unit down, there we go. So the vertex B is pretty easy. So if you take x squared, which is right here, and if you move it 3 to the left and 1 down, your new vertex is going to be right there. This is your vertex. That is your h, and this is your k. And that's the same thing as the x and the y. So your h is a -3, and your y is a -1. So it's a -3 and a -1. Now the top part is a little more brain power to figure out this top part. Okay, the top part, you've got this. You've got x plus 3 squared minus 1. They want the roots, so they want the zeros. So I'm going to clean this up mathematically. X plus 3 squared is the same thing as x plus 3 times itself, x plus 3. And that is going to be x squared plus 6x plus 9. And then I got minus 1. So that's really x squared plus 6x plus 8. Now, if I can factor this, x squared plus 6x plus 8, and I can, that's going to be x plus 4 times x plus 2. That's easy to find the roots. If it's factored, you can use the zero product property. What are you going to put in place of x to make a 0? You're going to put a -4 into this one, and you're going to put a -2 into this one. So your roots are going to be a -4 and a -2. Okay, call this one it. Last one for part 1. So part 1, okay, you need to draw your own line, but it has to have a constant rate of change of 1. So that means it's going to be linear. And your window is anything, x has to be anything greater than 0. So on my x number line, there's 0. So x has to be anything greater, so it can be anywhere over here. But then the y has to be anything greater than 2, so on my y number line, here's 2. Anything greater than 2 is anything here, So the window that they want you to play in is right here, kind of in quadrant 1. That'll satisfy both the domain and the range. So as long as it's more than 2, so I could start at 4, but now your rate of change has got to be up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. It's got to be constant rate of change of 1. So your line could look something like that. There's more than one right answer. There's several right answers.